Hello, so today we are going to do this problem, which is part of Leetcode daily challenge. Length of longest subarray with at most k frequency. So basically we have an array of numbers and we have an integer k, and we have the concept of frequency, which basically is just the number of times an element is in the array. And the array is good if the frequency of each element is less than or equal to k. And the goal here is to return the length of the longest good subarray in the array. So how do we do this? Well, first let's just think about brute force. Of course, brute force won't work because the time constraint, the length can be 10 to the power of 5, so brute force would be 10 to the power of 10, so that won't work. But just to think about it, I will show quickly the brute force solution. And you roughly need to just go through every subarray, so that's what we are doing here. And the subarray is this, and you can just get the frequency of every element and make sure that all frequencies are less than or equal to k. If that's the case, take the max between that and whatever value we have for the length before, and take the length of the current subarray, right? Very straightforward, but we have this O(n squared. How do we solve for that? Well, the first thing to think about is we're asking a contiguous subarray. Okay, and we have a condition with some function that is smaller or equal to k. And this you should immediately, when you have first the constraint of contiguous subarray, and then you have some function that depends on the values you pick, then you should immediately think about sliding window, because it really usually works for these cases. Sliding window is two things, okay? We need first to know when do we expand our sliding window, and then when do we when to collapse our window. So this, and then the other thing you of course need as well is how do you represent the window values as well, right? So let's think about this. Well, the window values itself, it's easy to think about because we need to keep count of the frequencies that exist in the array. So we need the occurrences or the frequencies. And then for that, we can just use either a hash map, right? Or you could use a counter like in Python. Okay? So this one is easy. If we do that, then we should be able to just check in the window, right? But how do we expand the window? Well, the condition that we need for a valid window, according to the problem, which basically a window where we can consider as a good subarray, is when the count of all the elements is smaller or equal to k. This is what a valid window is. And so usually what happens is you expand as long as you have a valid window, okay? And you shrink when you don't have a valid window. Why is that? Especially in this case, where if you increase the window, you only have a chance to increase the count because you increased the window. And so if one of the counts is already bigger than k, there is no need to expand the window, because if you expand, it will only get worse. You will never get to this again because you already have one element that is bigger than k. Okay, so when do we collapse the window? If any count is bigger than k, then we should collapse our window, because if we collapse, that means we reduce the number of elements, so we have a chance of reducing this count to less than or equal to k. Otherwise, we just expand, which is we expand as long as we have this. But you can also think of this as just the else case, right? Okay, so now with these, we should be able to do our sliding window technique. Now with sliding window, you usually have two things you can do. You can either use an approach with I and j, and you can do a while loop with either one less than the other or I less than n. This is just for the template for sliding window. But another approach, which is easier, is to just do a loop for the j value, so for the right part, and then for the expand part, right? And then you do the expand operation. And then in here, you do check if we have collapse condition, which in our case is this one, right? If we have it, then collapse. Okay, we do the collapse operation, which basically means moving I to the to the right, sorry. Okay, and then for every iteration, you just calculate the goal that we are working towards, which in this case is the length, the optimal length. And this is sort of the template you can use for a sliding window, okay? But before that, let's actually just apply it on an example, just make sure that we actually understand it as well. So if we just do something like this, so this is one of the array, k is equal to that. So what happens? So our sliding window, first we have I here, I'll actually put this. So we have I here and j here, right? So we have our I and then our j. Now, what is our occurrence window? So our window, which is going to be just the frequencies, first we have just I equal to 0, so we have 1 occurred once. Then we will move our pointer, again, we move j, right? Because they are all smaller than 2, so we expand. So our j is now here, okay? And so if we expand, what happens here? We have 1, 2. Okay, and now both are still smaller than 2, and so we can move j here, and then now we have 1, 3. Okay, and so we can still expand because the expand condition is still valid, so we put our j here, and now we have 2 1s. Okay, it's still smaller or equal to k, all of them still smaller or equal to k, so we can still expand, so expand here, and now we have 2 2s and still smaller or equal to k, so still valid. We move our j here, and now still valid again. Now what is the best length? I forgot to calculate it, but the best length so far is going to be the length from 3 to 0, and so that's 3, 6, that's 6. Okay, and so all of them still smaller or equal to 2, right? And so we can still expand, but now is where that's no longer the case, because we have now 3 1s, which is bigger than k. So what do we do in this case? Well, in this case, we just shrink. So what does shrink mean? Well, we can just move I to this position. Okay, so this means we need to reduce the occurrences of 1 by 1. And so now again, it's valid because all of them is more equal to k. So what's the length in this case? Still 6, so best is still 6. And I'll stop now, but you can still run through the rest of the example just to make sure you understood it, but that's the basic idea here. Okay, so let's just apply then what we just saw in the overview. So we said we need to keep track of the occurrence for the window, and so that's just going to be a counter. You can use a hash map if you need to. And then for the expand operation, we just increment the number of the frequency of this element, j, of the element at position j. Now we want to check the collapse condition. I said this is the collapse condition, right? We want to keep collapsing as long as we still have the collapse condition. This is very important. So while we have collapse condition, do the collapse operation, right? Now I know this is open, this check here, so we'll need to optimize it later, but for now, just to go step by step, we'll keep it. So while this is the case, we want to decrement j by 1, right? Because we move the window, sorry, I. Just like we did here when we moved I from 1 here to 2, we removed this one from the number of occurrences. So that's exactly what we need to do here. Okay, and we can increment I. Okay, and then now we need to calculate our goal, which is the length. We need to, what would be the length? This is from I to j. The current window is always from I to j. And so the window size is j minus I plus 1. And at the end, we want to return that value. Okay, so let's run this. Looks like there is small, so this is the occurrence. Yeah, sorry, I need this to just change the name. And this needs to be, we need to define I as well, so like this. So sorry, there is a typo in my condition here for the collapse window. We don't need all of them to be bigger than k, because the problem says all need to be smaller or equal to k. So if any of the counts or the frequencies violates this condition, that means we need to collapse the window. So this needs to be if any. And so let's just fix that here. And let's run this again. And of course, this one is slow because we are doing this entire thing. And we'll think about how we can improve it. So you can see it gets TLE. So how can we optimize this? Well, this needs to be just an observation. The observation you can make is that if you look at this condition, when does this happen? This only happens if the occurrences of aj is bigger than k. Because why? Because this is the only thing that we changed prior to the comparing this iteration to the previous one. The only difference is the increase of this value. So if this would ever be true, it would be only because we increment this. Because if it's not because we incremented this, what does this mean? This means that from a previous iteration, the count of either this element or another element became bigger than k. But if that was the case, we would have collapsed it already and made that no longer the case, right? And so the only case where this would be true is if this operation made this value bigger than k. So we actually don't need to check all of them. We just need to check if the occurrences of this value is bigger than k. Okay, because this is the only thing that changed. So this is the only thing that can be bigger than k. Okay, and so that's pretty much it. That's the operation. And if we do this, you notice now this operation, this check here is constant time. Okay, and so if we run this, it should work. Looks good. Let's submit. And this passes. Okay. And this operation is the kind of time complexity where if you take it overall, the number of time it will run, it can be more than O(n). Okay, so this would be pretty fast. And yeah, that's pretty much it for this problem. I think this is a good example of sliding window, and it forces you to think about a way to optimize your collapse condition. Yeah, so that's pretty much it. Thanks for watching and see you on the next one. Bye.